want to begin with the discussion for assignment number 2, and also the discussion of any questions that you were not able to solve from the test on Sunday, the minor test, the major test which happened on Sunday. So let's start with discussion of assignment 2 of Newton's laws of motion. So please let me know, are there any particular questions you want to discuss from assignment 2? Okay. Yeah, Shikhar, specifically if you tell me some questions, I mean, you will be able to solve some questions at least, okay? But anyway. If you just go through the class examples we have done, particularly in sessions 3 and 4, you will be able to attempt the questions. Okay, fine. So let's start with question number 2. Okay. Rudra and Shravani both asked from question number 4 onwards, but I will start with question number 2 because there's that question I want to discuss. Okay. So in question 2, see what is happening is that we have a sphere or a cylinder or whatever that is like this. I think it's a cylinder, which is, yeah, which is kept against the corner of, I mean, against two corners of some kind of, planes like this. So two contact points means that it is supported by two normal reactions, which are cumulatively balancing its weight. Now, that is the concept of the question. So suppose so this is the physical situation given to us. So there are two corner points against which it is resting. So both the corner points are applying some individual contact force, which will be a normal contact force. So the important thing is that the contact force will be along a direction which is, first of all, this is also given to us that if we join the center point with each of these contact points, let's say this is the center point. And this angle is 60 degrees and this angle is 30 degrees. This angle over here is 60 degrees and this is 30 degrees given to us. Okay. So the whole point of this question, actually, the whole idea of this question is to understand that when you have a body like this, like cylinder or a sphere or anything which has a round circumference like this, Okay. And it's in contact with a corner point like this. Let's just understand this point separately. Okay, then the plane of contact becomes this. The tangent at this point becomes the plane of contact. Now, at that corner point, whatever the tangent is, that becomes the plane of contact. So just let me draw it a little properly. So the normal reaction will be perpendicular to the plane of contact. Okay, so hope you're understanding that point. So normal reaction is perpendicular to the plane of contact, means it will be like this. It will be in the direction which is radial, because it's a circular circumference now. So whether it is a sphere or a cylinder, the circumference is circular in nature. Okay. So normal force means perpendicular to the plane of contact. Now the plane of contact is along the tangent line. So normal to it or perpendicular to it means that it will be radial or towards the center. Okay, so this is the plane of contact at this contact point over here. So the contact force, the normal reaction contact force at a corner like this will be perpendicular to this plane. So it will always be in a direction like this, which is at 90 degrees. Okay, and therefore it is passing through the center. That is the general rule of thumb in any situation like this. This is where the center will be. Okay, so the plane of contact is basically the tangential plane. So the normal reaction acts along the line, which is what we call the radial line, no, or it's along the radius at that point. Okay, Shikhar, I'll come back to question 1 also. Okay, so let me complete this. So here, if this point of contact is A and this point of contact is B over here, so we can see that there will be two normal reactions at A and B. So what will happen is, if we make a detailed diagram of the whole body, okay, so the point A is, let us say, over here. Okay. And the center of the cylinder is, let's say, over here. Okay. So the direction of the normal force which is acting through the point A, that will be along this direction. This is the contact force, or the normal contact force, or the normal reaction force between at the corner A, which is acting on this. Similarly, the other point of contact is, let's say, B over here. So that will be also applying a normal reaction force directed towards the center. Okay, so that is, let's say we call it NB. So that will act along this line. So these are the two contact forces which are acting. Okay. Because there's a contact point at B over here and there's a contact point at A over here. Now from the above diagram, you can verify this, that the angle for this here will be 60 degrees and the angle for this will be 30 degrees. Because see, that's what the diagram above is telling us. The given diagram is telling us that this is the situation of the angles. Okay. And apart from that, of course, there'll be weight acting. So when we make the free body diagram, remember in the free body diagram, we don't need to represent the cylinder with its proper shape and all that. We just need to show it like a particle. Its mass is m. So we just need to represent its mass with a point mass like this. So on this point mass, now you can see what are the forces which are acting. There will be this normal reaction due to E. There will be this normal reaction due to the contact point B. And of course, there will be the third force, which is its weight. Okay. And we can also see that with respect to the vertical and the horizontal, we draw the angles. So just comparing this diagram with the side one, this is along a direction which is making 60 degrees with the vertical. So over here, NA is along that direction which is making 60 degrees with the vertical. And similarly, NB is along a direction which is making 30 degrees with the vertical. So this is your free body diagram. And this body is at rest. It's an equilibrium. So the net force should be 0. Okay. So net force should be 0. So we can use Lami's theorem, for example. Equilibrium of three forces, Lami's theorem is always convenient. So mg upon sine of the angle opposite to mg, that's 90, will be equal to Na sine of the angle opposite to this. So that's this. So this angle 180 degrees, you can see, and that should be equal to Nb divided by sine angle opposite to Nb. So that is this angle here, 120. This is the easiest way of solving this particular question. Whenever we have equilibrium of three forces, Lami's theorem is the easy method. Okay, so as you can see, mg becomes Na divided by half, or Nb divided by root 3 by 2. So from that you can see that, sorry. Okay. So these become your answers. Or alternately, you can do one more thing. You can resolve the forces. Okay. So if you resolve the forces, you can see that the components of Na will become like this. This component will be Na cos 60, and this component will be Na sin 60. Okay. And the components of Nb similarly, this component will be Nb cos 30, and this component here will be Nb sin 30. And mg is already vertical, so we don't need to resolve. Okay. So now balancing the forces along the vertical, you can see that Na cos 60 plus Nb cos 30 is balancing Mg, or Na by 2 plus root 3 by 2 Nb is equal to Mg. That's equation 1. And along the horizontal, you can see that Na sin 60 is balancing Nb sin 30. So from this we can conclude that root 3 Na is equal to Nb. That's your second equation. Now you can solve equation 1 and 2 simultaneously, and you will come to the same conclusion. You will come to this conclusion. Okay. So particularly if you haven't done this question, or you are a little bit confused about how to take the direction of normal reactions, then understand this point over here. This is the very important concept over here. Okay. Normal reaction at a point of contact being a corner point type of point. Okay, for this could also have been a sphere. Okay, people, hope this question is clear fully. Yeah, Ritika, I've got your message. I will come back to question number 1. Okay, so moving on to part 1 of question 1. Okay, so let us look at this situation here. So we have a combination of two blocks which are in contact, and they're both lying on a horizontal surface like this, which is smooth surface. Okay, it'll be quite some time before we come to rough surfaces. So all surfaces for us by default will be smooth. Now this one is of mass m, this one is of mass 3m in this case. Okay, now the first part is very simple. You can see you are applying a force F from this side and an equal and opposite force F from this side. Okay. So you can see that if you think of it like a system of mass m plus 3m, you have equal horizontal force from both the sides. Vertical forces are both balanced, of course, so acceleration will be 0. Okay, so in this case we can see that both blocks will be at rest. So from that you can understand now, if you were to calculate the individual forces on each of the blocks or the normal reactions and all that, the contact force, you can understand that very easily now. So for this block, for example, the forces are the external force which is acting towards the positive x direction. So that will push it against this block, and this block will push back with some kind of reaction force. Okay. And of course, there is this one's weight, and the ground is applying a normal reaction on it. Okay. And this is at rest. So F is equal to R, and mg is balanced by n1. Okay. Now similarly, if you see the second block, you will get the same result for it. The only thing is the normal reaction due to the ground will be different because its weight is different. But the horizontal forces will have similar magnitudes, just their directions are opposite. Here the external force is acting along the negative x direction. Okay. And also here the mass of the block is 3m. So this one's weight vector acting downwards is 3 mg. And normal reaction that the ground is applying is like this, and that will also be 3 mg in magnitude. So this is also at rest. So you can see again F is equal to R, but this time N2 is equal to 3 mg. So this and this R, you can see, are an action reaction pair. One is the force that the block M is applying on 3m, the other is a equal and opposite force that 3m is applying on M. Okay, and they are, so R is basically the normal reaction contact force between the two blocks. So just understand this part over here, and similarly now make free body diagram for second part. Okay. Understand what the situation will be in the second part. I'll put it up very soon, but just try it yourself. For the second part, try to understand what kind of forces will act and how we'll write the equations for those forces. Okay, now see, Ritika, what we have to understand in the second part is the forces are acting in the same direction. So net horizontal force on the system is 2F, but that doesn't mean that they will be in contact, no, while they are moving. They could also lose contact. So that is the thing we have to check. Again, the masses are m and 3m, but we are applying forces, a pushing force on this one, and this one is being pulled with a force F. Okay. You can understand it this way, that suppose the blocks had been separate blocks. Okay, suppose situation had been like this, that there is actually some gap between the two blocks. Like this. And you are applying forces of same magnitude and in same direction on both of them. Then what would be the understand that? Okay. If we assume that there is some gap between the blocks, so okay, suppose this was the case, then this one would have an acceleration, whereas this one would have an acceleration of f by 3m. Okay. One acceleration, let's say a1 of f by m. This one would have an acceleration a2, let's say, of f by 3m. So that is actually a1 by 3, 1/3 of a1. So this would be moving slower. This would be moving faster. Now you can see that this situation here is not possible. So what is happening here is the block A has a tendency to move faster because of the force F that we are pushing it with compared to the block B. So what happens is it pushes against B. So therefore A pushes B while they move together. That means they move while they are in contact. That is the point over here. Okay. So they will have a common acceleration. They will not be moving with different accelerations because they cannot move in such a way that the block. It's not easily possible. So it is actually pushing against the second block. What is happening? Okay, so this point is clear. This is the situation. Suppose they were separate. So if they were separate, then there's a tendency for A1 to be greater than A2. But that situation is not possible over here. When they are in contact, I mean, to begin with, they are in contact. You cannot set off the motion in such a way that while they are moving in the positive x direction. So that means they have to be moving together and there has to be some contact between them. There has to be some force between them. So with that, we can now see that, okay, your free body diagrams are very similar to the first. Only difference is the direction of force on the second block is a pulling force and not a pushing force. So the correct free body diagram here will be that force F on this, force F on this also, but there is some kind of a reaction force between them. Which will be like this and like this. Okay, so for the block A, the horizontal equation will become like this: F minus M is equal to MA. And for the block B, the horizontal equation will become like this. Sorry, F minus R. Okay, F plus R is equal to its mass, which is 3m into A. So from this we can now find out. Okay, so for example, if you add the two equations, you will get 2F is equal to m plus 3m into A. So the magnitude of that common acceleration will become F by 2m, 2F by 4m. So that also means this. So it will be 3 by 2 minus 1 F. So the normal reaction contact force between the two blocks will be F by 2 in magnitude. Okay. So this is the contact force. Of course, there are the vertical forces also, which I have not shown in the FBD. Okay, because they are balancing each other. So that's not really necessary. There is mg and normal reaction on this one. And there is this one's weight, which is 3 mg. And the normal reaction acting on this one. Okay, so just make a note of this, and next up we will do one more part of this question before we move on to something else. Okay, so let's do the fifth part next of this. Okay, try the fifth part yourself. Okay, so see what is happening in the fifth part. Hope you people got the answer by now. So in the fifth part, this block is of mass 2m and this block is of mass m, and you are applying a force 2F on this and you are applying a force F on this. Okay. So if you assume that they are not in contact and you want to separately see what their accelerations are, see is equal to A2, which is equal to F by M. Okay. So that means when they are placed in contact, they will have a tendency to move together, but with okay. So this together with an acceleration of F by M, but with no contact force between them. Okay. Because if you make their individual free body diagrams and assume some contact force also, you will see that that contact force will come out to be zero. If you assume there is some reaction force and you write the equations, you will see that the values of the external forces are such that that reaction force is zero. Okay, so for the first block you have 2F minus R is equal to its mass 2m into A. For the second block we have F plus R is equal to its mass m into A. So if you solve these two equations, you will get the solution set that A is equal to F by M and R is equal to 0. So this is the case where there is no contact force between the blocks. Okay, so this was the fifth part of question number 1. And similarly, the other parts you can handle. Okay. Now let's move on to fourth question after this. Pepper. Okay, so fourth question, you can see that one string is like this at 60 degrees to the vertical. So let's say it's like this. And the other string is at 45 degrees to the vertical. So let's say it's like this. And there is a block attached like this. So this angle is 60 degrees. This angle is 45 degrees. This string is, let's say, A, this string is B, and this string is C, and we have to find the tensions in each of the strings. Okay. The mass of the block is given 15 kg. So what is the tension in each of the threads? Okay. So let us say that tensions are E in this thread, let's say this thread. Okay. And this one, let's say TC. The free body diagram, straight away understand that is Newton. There is TB acting like this. Okay. And there is TC acting vertically downwards. Yeah, I just got disconnected for a moment, but I'm connected again now. So we will just continue ahead. Yeah, so coming back to the free body diagram in this question number 4. So at this point where the three strings are connected, you can see these will be the forces. So the condition for equilibrium here you can see is that you can write Lami's theorem also, or more conveniently you can just resolve the forces. So if you resolve the forces, there is TA sine 60 in this direction and TA cos 60. Then TB's components become TB sine 45 and TB cos 45. Okay. And of course there is TC which is acting vertically downwards. And from here we can see that TC is equal to 150. So now balance the forces. Okay. So root 3 by 2 TA plus TB by root 2 will be equal to TC. That's your first equation. And TA by 2 balances TB by root 2, second equation. So solve equation 1 and 2 and you will get the tensions. TC you already got here. T and TB you will get from there. All right, so pretty simple actually this question. Just complete this. Okay. People, if you can just send me the questions after question number 4 once again. नहीं, it's not making with the negative x-axis बेटा. देखो TA ये act कर रहा है. हाँ. See, TA is acting along this line where this angle is 60. So that's why we have taken this angle as 60 degrees. So this component will be the cos component. No? This will be TA cos 60. And this component will be the sine component. This will be TA sine 60. Yeah, Rakshit, the first equation is just coming from balancing the vertical forces. So these two forces, TA sine 60 plus TB sine 45, that these two, they are balancing the downward force, which is TC. Understood it? All right, moving on to 9th question after this. Yeah, I've got your messages, Rakshit, Ritika, and Shravani. Yeah, Rakshit, you understood this, no? There is no normal force, Shikhar. यहाँ पे कोई normal contact force है ही नहीं ना. The block is not in contact with the floor. It's hanging on the. It's hanging in air because of the two strings. That's why we are not considering any normal force. No? Normal force is only there where there's some contact surface. Yeah, so I've got your messages, Rudra, Shravani, and Rakshit. Okay, so we will be moving on to and Ritika. So we will move on to question number 9. Next, we'll do 9 and 10. So 9 is actually very similar. Now you try it out yourself. I think you should be able to get question number 9. It's very similar to this. Only there the angles are theta. Here the angles were given 60 and 45. So you'll get your answer in terms of theta. Achha, theta is given 30 degrees. Okay. It's actually an easier problem. Just give it a try. So I have this 2 kg block, which is again suspended from the ceiling. But this time the two strings, they're at symmetrical angle of 30 degrees each with respect to the horizontal. Okay, so this angle is 30. This angle is 30. So now again, if we take, so this time actually these two tensions will become equal. TA and TB will become equal. However, let's start by just taking something else. TA and TB, and so you can see TC will be equal to the weight, and you have this kind of situation. So the horizontal components will be such that TA cos 30 balances TB cos 30. That means TA is equal to TB. That's your first equation. And along the vertical, you have TA sine 30 plus TB sine 30 is balancing mg. So you have TA plus TB by 2 is equal to mg. That's your second equation. So just solving these, you will get equal to mg. Now, if we take a general value instead of theta, or instead of 30 degrees, take that angle as theta, general value. Then your equation 1 and 2 will become like this. Okay. So from this you can see, जितना छोटा theta होगा, TA and TB will be accordingly large. So you'll see that the smaller the value of theta, okay, the larger will be TA and TB. So we have the condition here that therefore TA equal to TB will be tending to infinity, okay, as theta tends to 0. Okay, Shikhar, there should be no confusion with the angle. Let me explain again. So if you have a string over here where this angle is theta, है ना, तो ये वाले पॉइंट पे जो टेंशन एक्ट कर रहा है, that is acting like this. Okay. So this tension is just geometry, beta. You don't, it's nothing very complicated. You just pay attention to how to get these angles geometrically. So this angle theta will be equal to this angle theta, na? Because this is horizontal and this is also horizontal. So why should there be confusion with these things? Huh? Okay. If you like, just go through your class 9, 10th maths textbooks once and revise all these concepts of, you know, corresponding angles, vertically opposite angles, and these kind of things. No. It's nothing more than that. It's just plain geometry. Okay, let's come to 10th question. Now, 10th question is a more, um, vector algebra type of question. So in 10th question, what is happening is it's given to you that there are two forces acting on a body. Okay. There are two forces acting on a body, and one of them is shown to be along the x-axis. So this is our x-axis, this is our y-axis. Okay, Ritika, I'll just give you some time to write down this question. Then we'll come back to 10th question. Okay, finish writing this. We'll come back to 10th. Okay, done, Ritika. Oh, right. So now in 10th question, see what is happening is there is one force which is acting along the x-axis, and its magnitude is given to us of 200 newtons. So in this diagram, one of the forces acting supposedly on this block is like this, and it's 200 newtons in magnitude. Okay. Now there is some other force F2 which we don't know about, but we are also given the acceleration vector. Okay, so it's first of all there are only two forces, F1 and F2 acting on the block. F1 is shown to you, F2 we have no information about, but we also know that the acceleration of the block is a vector like this. The acceleration is making an angle, I mean it's in the third quadrant, such that this angle is equal to 30 degrees. Okay. And the magnitude of the acceleration is 12 meters per second square. And of course, also given to us that the mass of the block is 2 kg. So the concept we have to use here is that net force is equal to mass into acceleration. So net force here will be F1 plus F2 is equal to mass into acceleration. Now see in this equation, F1 is known, mass is known, acceleration is known, and we have to find F2. So this is how you will solve. Write F1 and A in component form. Okay. So first step, write the force F1 and the acceleration A in component form or I cap J cap form. Okay. And substitute in above equation. Okay. And from that you will easily find out F2. So just work this out. So to be very careful now and write the acceleration vector A properly in I cap J cap notation. So take into account that it's in third quadrant and all that, and make sure you get the components correct. Once you get the components correct, it's just solving a vector equation in component algebra, nothing else. Just try this out. Okay. Yeah. Okay. Very good. It's correct. Okay. So let me just so Shikhar, Vaishnavi, I've got your answers. Ritika, you also. Okay. So let's for the benefit of others, let me just illustrate. So you can see here this acceleration vector. Okay, it will have an x component of minus 12 sine 30 and a y component of minus 12 cos 30. So the acceleration vector will be minus 6 I cap minus 6 root 3 j cap. Okay. And F1 already you can see nothing saying about F1. So F1 plus F2 should be equal to MA. So 200 I cap plus some unknown force F2 should be 2 kg multiplied with minus 6 I cap minus 6 root 3 j cap, which is in meters per second square. So we have F2 will become minus 12 I cap minus 12 root 3 j cap minus 200 I cap in newtons. Okay. So this should be the answer in newtons for F2. All right. So that is. So people have got this right. Those who have sent me the answers. Okay. Next up, we will do question number 14 and 15. So these questions are just about understanding the language of the question. So what is happening in 14th question is that you are using a steel wire to lift up a load. Okay. So suppose the tension in the steel wire is T and you are lifting up the load with an acceleration of A. So you can see that when you make the free body diagram of that weight, the situation is like this, that T minus mg is equal to ma. So the tension is mg plus A. Okay. Now the maximum tension the steel wire can withstand is, how much is it now? It is 4,400 newtons. Okay. And the weight of the block, okay, and mg, load means basically mg, is given to us as 3,900 newtons. Okay. So So that's it. Now from that you will get the maximum acceleration. So in this, when you substitute tension as the maximum possible tension, the corresponding value of A on this side is the maximum acceleration. So this is the maximum tension. This is equal to the weight plus m into A max. Now m we will just take as the weight divided by g, 390 kg. We'll take g as 10 over here, and from that we'll find the A max. Okay, people, so that is the 14th question. Now let's move on from that to the 15th. So 15th is more about the language of kinematics, the question actually. So it is said that the force acting on a body is 10 newtons. Okay. And the body moves in a straight line, so that the relation between distance moved and time is given by s is equal to this. Okay. Where c is equal to 1 meter per second square. So from that we have to find the mass of the body. So it's very much like this, that first we use Newton's laws. So F is equal to ma. So 10 newtons is equal to mass into acceleration. Then you use this relation that acceleration is second derivative of displacement with respect to time. Okay. So ds by dt, which is the velocity, will become differentiation of this term. Sorry. So that is minus b plus 2ct. Therefore, d2s by dt square, which is nothing but rate of change of velocity or acceleration, will just become differentiation of this term. Very basic stuff. Okay. So the acceleration you can see will become twice of c. This is your second equation. And c is given to us as 1 meter per second square. So using this relation now, you can see that the acceleration is equal to 2 meters per second square. So substitute that here. So the mass will be equal to 5 kg. Okay, so that completes the discussion of this. Now let us move on to the test paper if you have any doubts. Acha, Shikhar, you want to discuss question 12. Okay. Okay, so next we will look at question number 12. So in 12 it is saying that the weight of a firefighter is 712 Newton. Okay. So mg is equal to 712 Newtons. Okay. And that firefighter is sliding down a pole with an acceleration of 3 meters per second square. Okay, so when he's sliding down against the pole, basically you can see there is some friction between his arms and legs versus the pole, which is preventing him from free fall. So if you see his body, it's experiencing weight, but it's also experiencing some kind of friction. If he lets go of the pole, the friction will become zero. So his acceleration will become equal to g. So you have mg minus that frictional force is equal to ma. Okay. So 712 minus f is equal to 712 by g, that's his mass, into acceleration. This acceleration is 3 meters per second square. So that frictional force will become 712 into 1 minus E by G, where E is 3 and G you will either take as 10 or 9.8 depending on the question. So what are the vertical forces on the this thing, on the firefighter? They are weight and that frictional force. And similarly on the pole, what kind of force the firefighter applies? He applies a downward frictional force, because this and this are an action reaction pair. Okay, Shikhar, so hope this question is clear to you. Okay. Okay, we'll look at question 11 also quickly. It's a very simple question. Some unidentified person has asked question number 11. It's a requirement in these lectures to please log in with your name. Okay, next time somebody logs into the lecture with no name or with some different kind of login ID which does not have their name, I will disqualify the person from the lecture. Okay, so please make sure that in future you log in with your proper name into the Zoom conference. Okay, so you have frictionless ice surface on which there is a person, a girl, who is okay pulling against a block through some thread or rope or something like this. Okay, so this is a person of mass 40 kg and this is a sledge. Sledge is something that can slip on the ice. It has a mass of, how much is it, 8.4 kg. Okay, and this rope, it has a length of 15 meters. Okay, now what happens is that the girl starts pulling the rope with a force of 5.2 newtons. Okay, so what will happen is, considering the rope to be massless, which is the case over here, on the rope, if the girl is applying a force from this direction, which is 5.2 newtons, now the rope will develop a tension like this, and that tension will be equal to 5.2 newtons. Okay, tension will become equal to the force that she is applying. So now if you see the girl's free body diagram, on her there is tension acting, giving her an acceleration a1. And if you see the sledge's free body diagram, this, okay, this is mass m1. Vertical forces are balancing normal reaction and weight, so I'm not showing them. So a1 will be equal to T by m1. So that is 5.2 newtons divided by 40 in meters per second square. Okay, so that will become 0.13 meters per second square. And if you see a2, that will become T by m2. So that is 5.2 newtons divided by 8.4 kg. Okay, so that is how much? 52 by 84. So 13 by 21 meters per second square. Okay, so now you want to calculate where they will meet, है ना? At how much acceleration of the girl तो हो गया, acceleration of the sledge हो गया. How far from the girl's initial position do they meet? Okay, so for that you have to understand that they start like this with acceleration a1 and a2, and this distance equal to 15 meters. So after some time, if this becomes the case, going on pulling the rope, they meet here. So the girl's displacement is s1, the sled's displacement is s2. So s1 plus s2 should be equal to 15 meters, and s1 is equal to half a1 t square, s2 is equal to half a2 t square. So that means s1 by s2 is equal to a1 by a2, which is t by m1 divided by t by m2. Okay. So s1 is to s2. It's your second equation. Now solve these two equations and we'll get the answer. Because they're starting from rest, Baba, that's given to you. You're not starting with some initial velocity. There's nothing given that they're initially in motion. So they're starting from rest. You understood, Shikhar? Okay. All right. So that was about this. Now, let's move on to the test paper from Sunday. So in the Newton's laws problem, if you have any doubts, we will discuss in class. Whereas vectors questions, if you have any doubts, you can just send me individual messages later, or during the doubt sessions, you can discuss with me. Okay. I will not be discussing the vectors doubts from the test in the lecture today, but I will be discussing the Newton's laws doubts if you have any. Okay. So just a moment, I'll bring up the paper for you so you can go through that. Okay. So the first question is, I think, simple enough. It is to do with forces, but it's very simple. You have to just find F1 plus F2 first and then apply the condition that is given. So I don't think you should have any difficulty with this. Yeah, let's come to this sixth question. Does anybody have a doubt in the sixth question? Sixth is clear to all of you? Okay, seventh question, Shikhar, you have a doubt, so I'm coming to that. Yeah, so this is question number 7. Yeah, Rakshit. So what I suggest is start by making a free body diagram. So in seventh question, make the free body diagram for the block first. So in that free body diagram, you can see what all forces will be acting. There'll be weight acting downwards, normal reaction acting like this, okay, and the net force should be 0. So the net force should be the vector sum of this force F, the normal reaction which I've drawn over there, and the weight which is vertically downwards. This should be 0. So solve for this condition. Okay, I'll put up the proper diagram with the angle and resolved forces and all very soon, but just try it yourself. Yeah, Rahil, I will come to the neat paper also after this. Okay, so let me explain the free body diagram in detail. So see, the main thing you have to remember is that if you have an inclined plane that is at some angle theta to the horizontal, in this case that theta is 37 degrees, okay, then the normal reaction on an object over here will always be in a direction which will make that same angle of theta with respect to the vertical. So ये जो line होगा जो इसके normal है, if you compare that with the vertical direction which is like this, then the main important thing is that this angle will be the same. It will be theta equal to, in this case, 37, always theta, you know. So that is the thing. You have normal reaction, you have weight which will act along the vertical direction, okay, and in this case I have applied the horizontal force. I mean, I've applied this force horizontally, so you have F like this, and this block is supposed to be in equilibrium. So if we make a free body diagram with only the forces showing, the forces will be like this. F is acting at that point horizontally, okay. Normal reaction is acting perpendicular to the inclined plane, and mg is acting vertically. This angle is theta, okay, and this angle is 90. So for equilibrium, the vector sum of these forces has to be 0, okay. So you can use Lami's theorem again. So you can see that n upon sine 90 should be equal to F upon sine of 180 minus theta, this angle here, should be equal to mg upon sine of 90 plus theta. That is this, okay. So n will be equal to F by sine theta will be equal to mg by cos theta, and theta is equal to 37 degrees. So n will be equal to F upon sine 37 is 3 by 5, okay, which will be equal to mg upon cos 37, which is 4 by 5. So you can see that F is equal to 3 by 4 times mg, and n is equal to 5 by 3 times mg, or that is, sorry, It should be 37.5 only. The answer is 37.5. Let me just check. See, the answer is D, 37.5. Just check in the system again. In case it's showing an error, let me know. I will get it corrected. Okay. It might be a website error, but the answer to this question is D part only. Okay. Next, we will discuss this question. So just go through this properly. Question number 8, just go through it. Number of people have asked this. So okay, so let's understand here what is happening. So what you can do here to begin with is that you understand this whole thing as a system. So on that system, which is m plus m, the horizontal forces acting, if you see, the horizontal forces acting are from this side, this component of this, which will become F2 sine beta. क्यों sine beta होगा देखो, because F2 is a force acting such that with this axis the angle is beta. Now this angle is beta. So this angle is 90 minus beta. So that's why the components of this force will be, this component will be the sine component and this component will be the cos component. Okay. So anyway, so on this system, from this side there is a force like this, and similarly from this side there is a force of F1 sine alpha. Now work out the values. F1 sine alpha kitna hai? It is, okay, 60 sine 53. Okay, so that is how much? 60 into sine 53 is 4 by 5. So 48 newtons. Okay. And this one is 40 sine 37. So 40 into 3 by 5. So that is 24 newtons. Okay. So you can see that this system will have an acceleration towards this direction. And that acceleration will be F1 sine alpha minus F2 sine beta divided by the total mass. So it will be 48 minus 24 divided by the total mass, which is 20 kg. So 12 by 20. Okay. So 0.6 meters per second square. Oh, sorry, 24 by 20. My mistake. So it will be 1.2 meters per second square. Okay. Now, once you establish this, to find out tension, you make the individual free body diagrams. So if you look at the individual free body diagram of this block, there is F1, there is tension, there is weight, and there's normal reaction, and there's moving with an acceleration E. Similarly, the second one, there is tension, there is F2, there is weight, there's normal reaction, and it's moving with the same acceleration E. Okay. And further, this angle was alpha, this angle was beta. So further, if you resolve these forces, so for this one, there is F1 sine alpha and tension. These are the horizontal forces. The rest are vertical forces, we need not worry about them. And this is F1 cos alpha, normal reaction, let's say N1 and mg. But we need not worry about this. The main thing is that horizontal thing. So F1 sine alpha minus T is equal to MA. So from this we'll get the tension. So F1 sine alpha was 48 and MA will become 10 into 1.2. So tension, as you can see, will become 48 minus 12 or 36 newtons. So you just need this free body diagram. You don't even need the second one. However, you can use the second one to verify this result. You can see that the second one, tension T, now resolve this force F2. So F2 has a horizontal component of F2. Sorry, this angle is beta, my mistake, not this angle. Okay. So F2 sine beta, which we had seen was 24 newtons. Okay. So again, I'm not showing the vertical forces because they're not required. So for this, I'll get the equation T minus F2 sine beta is equal to MA. So just verify it. So T minus 24 should be equal to 10 into 1.2. That's giving you the same tension. So your equations are consistent. Okay, people, so hope you're following this also. Okay, good. Okay, so we have few more questions to go in this, but we're out of time, so we'll pick it up in the next lecture. Okay. So we'll pick up this question, the ninth question. I'll just give you a hint what to do in the ninth question. So in the ninth question, you can see that if you make a free body diagram of that sphere, so you can see on that sphere, there will be normal reaction from this side, and by symmetry, the two normal reactions will be equal because they are at the same angles. No? So you can see this will be such that okay, this angle, the inclined plane is making 30 with the horizontal. So the normal reaction will make that same angle 30 with the vertical. This angle will be 30. Similarly here, this angle will be 30. Okay. Plus there is tension acting like this and mg acting like this. Okay. So make the free body diagram in this way. Once you make the FBD correctly, you will get the answer. Okay. So you can see this is the FBD. And similarly, now this question I will discuss in more detail. Just a moment. Yeah. This question I will discuss in more detail, but the main thing to understand here is because they are joined by a thread, this one's magnitude of acceleration will be equal to this one's magnitude of acceleration will be equal to this one's. Okay. And if the tension, yeah, if the tension in this string is T1, then the same magnitude of tension will be acting on this block. And if the tension in the other string is, let us say, T2, then the same magnitude of tension will be acting here. Okay. And of course, here there will be some normal reaction acting in this direction. And apart from the forces I've shown here, there are also the weights of the three blocks. So make the free body diagrams of all three blocks. Okay. And in those equations, you have T1, T2, and acceleration unknown. So solve three equations. You'll need three equations to solve with T1, T2, and E. So those equations you'll get from the three FBDs. So that will be your method for solving this. Okay. So try out these questions and we will conclude today's lecture here. Okay. Okay, so that's it for today's lecture, people. And as I said, try out these remaining questions from Newton's laws part from your test paper. Apart from that, I'll also be sending you a worksheet and we'll pick it up from there next time. Okay. Also do a revision of all the questions we discussed in lecture number 5 before this, or lecture number 4 before this. You know, the one where we solve the pulley based systems and tension in strings and things like that, how to solve those type of questions. So do a thorough revision of that because we'll pick up the next set of questions and next set of concepts in the lecture, next one from there only. Okay. So that's it for today, people. Thanks for attending. Yeah, Priyank, I will be sending the recording, so don't worry.